our last question on exponential decay, all right? Here we go. It says to determine whether a person has a thyroid deficiency, radioactive iodine is actually injected into the bloodstream. But the radioactive iodine has a half-life of 8.2 days. Okay? And a healthy thyroid will absorb all of this radioactivity. Huh. Okay, so what they're going to look at is they're going to see how much is actually left in the bloodstream and be able to determine whether or not your thyroid is healthy. Interesting, right? Okay, so if you look at this, it says determine an exponential function that models the amount of radioactive iodine that should be present in a thyroid gland of a healthy person after a number of days. Okay, real simple. Think about this. This is a half-life question. So you want to know your total, right, equals to the amount that you put in, right, half-life, time it takes, over 8.2 days, which of course is your period. Well, there we go. That's an interesting enough of a formula. All right. Now, here's where the little nuance comes in. I love these little nuances. I think they're very, very interesting. It says, how long should only 25% of the radioactive iodine be present? Whoa, wait a second. What does this mean, 25%? You didn't give me how much you started with. Well, actually, you don't need to know how much you started with. It's based on a ratio of 25%. Think about it. If you've got your AT here, right? Okay, this is your total amount after all of the decaying, right? Here's the total amount that you started with. Isn't percent based on how much you have left over the original total? Yeah, so watch this. Here's the rest of the formula, 1/2 T over 8.2, but check this out. Divide this by A naught. There's your total. That was your initial amount, your total, which is A naught, right? That cancels out. What does that number work out to be? That number works out to be 25% or 0.25. There you go. There's your formula, 1/2 T over 8.2. All you have to do now is put this in as Y1, put this in as Y2, play around with the windows, and you'll end up with a T being 16.3 hours. See how it goes? Actually pretty easy to do this question, isn't it? Do you want me to show you how to do this on the calculator? Okay, people complain. I'll show you how to do it. I'll bring up the calculator here and let's see what we can. Okay. Y1 will be 0.25. Y2 will, of course, be, guess what? Yep. There's my fraction, 1 over 2, right? To the power of x. Oh, it's going to be a fraction again. X over 8.2. Right? Graph it. Look how ugly this graph is. Oh, my goodness. Right? It's just ugly. One of the reasons why I'm still on the Zoom standard or the Zoom window settings from the last question. But so what? Let's see if it works. Second calc. Find the intersect. 5. Enter, enter, enter. And look at this. You end up with your 16.4 hours, which is just perfect. I think I put down 16.3. Should be 16.4. Okay? Real simple questions, straightforward, easy to do.